Hey folks, let's get started today. So today is the fun stuff about Mars, and I think one of the main reasons anybody takes an astronomy class, which is, is there life elsewhere in the universe beyond Earth? We like to think about this. So we're going to talk a bit about life in the universe, what we kind of think, or how these searches are informed by what we know about life on Earth. We're going to talk about water on Mars, some biosignatures, potential biosignatures, so evidence of life that was recently discovered by the Perseverance rover. And we'll talk about some potential interesting things in the rest of the solar system, maybe beyond, depending on how much time we have. So this particular picture is a crater on Mars from this image was taken in 2018 by European Space Agency. It's Korolev crater. It's more than 50 miles across. It's near the North Pole of Mars, and that is completely filled with water ice. We've now determined. So, I mean, the question, is there water on Mars? We could very emphatically say yes. This was a big question for, we'll talk more about this because you can also have dry ice, carbon dioxide ice on the surface of Mars. So people weren't sure if it was carbon dioxide ice, which makes up the majority of the atmosphere, or if it was water ice. And now we're pretty sure that there's an awful lot of water ice on Mars. Life in the universe. So a lot of what informs what when we're thinking about life in the universe and what it could maybe look like, how we look for it, is informed by the fact that, we have a lot of life on Earth, and this is the only place we know that it exists in the universe. So we then tend to extrapolate. It's not that we think life is automatically always going to be exactly the same as it is on our planet. It's just that in a universe of infinite possibilities, you have to start somewhere. And we think, well, okay, if these conditions gave us life on Earth, then there's a reasonable chance that similar conditions could give you life on other planets. The first thing to note is we're pretty sure that all familiar life forms on Earth are related. So this is a very simple tree of life. So anything from the little bacteria to plants to animals to you to me, we're all related. And the way we're related is actually in the DNA that we have inside of us. So we have a common biochemical design. Every single life form on our planet has DNA or RNA in it, and that's how you pass on your genetic information to the next generation. So that's a very important one. The second one that's very important is water. So water is a common denominator on Earth in the sense that all living things need water at some point to survive. So I'm not saying you always need water, like you don't need to constantly drink water to walk around, right? You can wait a couple hours and things like that. Some things we're going to discuss can last much longer. But the point is, if you find water on Earth, you're going to find some sort of life forms. And the reason is water is an excellent solvent, and that triggers molecular movement. And then you need some sort of energy to sustain life, right? Every single creature on this planet needs some sort of energy to fuel itself to keep going on and then be able to pass on its genetic information. Water also is just a very unusual molecule. It dissolves more substances than any other liquid. It has a strange polarization um, and this partial charge that allows other things to attach to it. Yeah, so water is just a very, very unique thing. If you look at all the solvents, it's not that, there couldn't be other solvents, but water is just very common and seems to do a really, really good job of it. That said, we also know that there's life on Earth that can survive in conditions that we would not expect life to survive in. Um, so, for example, this picture up here is Yellowstone National Park. Who here's been to Yellowstone? Do you remember these beautiful pools of color and things like that? Do you remember what causes that? Yeah, so there is sulfur, but actually the color itself we think is due to bacteria that lives in that water. So the water is extremely acidic. That's what I mean by pH of 6 to 10. Extremely acidic, pretty much boiling. Like if you were to fall in, that's your last day and you die a painful death. But there is actually, it turns out, life living in Yellowstone National Park in these beautiful, very extreme temperature conditions. The nuclear reactor of 3 Mile Island. It turns out there's bacteria in there. Like when they were going around after 3 Mile Island, there's where there was all the radioactivity, bacteria. Huh, who knew? There's also hyperacidic lakes and volcanoes, acid mine drainage, all sorts of places like that that you don't think you should have any life existing. It turns out there will be some form of life in them. Well, when you look, often we find them type thing. Deserts and arid environments. There's areas on Earth, there's deserts where, you only get rain once every 10 years, and there's basically plants that will just wait for that rain and then pop up and then reproduce and carry on their merry way. And this is a final one. So tardigrades, which is the picture down here on the right, there's these little roly-poly tiny creatures. They have been exposed to space's vacuum for 10 days. I don't think this was deliberate. I believe it was an accident. They were on like a lander on the moon or something like that. And then they were reanimated on Earth via rehydration. So, you always hear that space will kill you and everything like that. It turns out some life can survive even for 10 days at least. A tardigrade is like a sponge where you can add water and then it pops back up. So the point of this slide is life on Earth can be very, very versatile, much more like we could not survive in these conditions, but there's creatures that will adapt to it. So that's pretty encouraging if you're thinking, okay, nothing has to be exactly perfect for life to exist there. On Earth, we also have, somebody was mentioning this on class, or asked about this last class. In history, there have been claims of meteorites from outer space that landed on Earth, and then people thought like, oh my gosh, this is proof that there's life. Like, look at this fossil in this meteorite. The most famous one is this meteorite here on the left, called Allen Hills 84001. It's a meteorite from Mars. We have ID'd that it came from the planet Mars, so there was some impact. The rock then came here and landed in Antarctica. And the scientists said that these features on the right in 1996 were actually fossilized microbes from Mars. So this caused quite a stir when this initial news came out, but then after that happened, the majority of scientists these days now say that these features could be formed via non-biologic processes. So without life form involved, just ordinary chemistry. So it's maybe there's some theories that maybe life came to Earth from other places, like it was an asteroid that landed and then the microbes went out and evolved from that. But we haven't really found definitive proof is the point of this little story. So okay, we talked about life on Earth. So we're now going to think about life in the solar system and where it could potentially exist in our solar system. So Mercury, no, it's pretty hot. And there's no atmosphere. You guys heard it's not a terribly hospitable place for life forms, we think. Venus, surface, definitely too hot. Atmosphere, maybe. So there have been some claims about life in the atmosphere, so we're going to discuss that. So as we discussed on Monday, man, it's been a long week. Venus's surface is the closest thing we know to hell in real life. You definitely don't want to be there because it's well above boiling temperature. Lead would melt there. The surface pressure is about 80 times that of our own planet. It's a pretty not nice place to be. However, the atmosphere about 50 kilometers up is actually not that bad. It's comparable to Earth, and the pressure and temperature are Earth-like. We also know that on our own planet, if you go up to the upper levels of our atmosphere, you can have like life forms that are like I'm not above like where birds fly. Obviously, birds can go pretty high up by our comparison, but you can have like bacteria flying on the breeze and things like that, even tens of kilometers up. So what ended up happening? So a couple of years ago now, there was a huge claim. It was during the pandemic, so we were all at home and very excited about this because nothing else was going on. A group of astronomers announced the detection of what is called phosphine on the upper cloud decks of Venus. So phosphine is what is called a biosignature. So a biosignature is a chemical signature indicative of past or present life. So basically, the only way that we know it exists is life is actively putting it out into that environment. A good example of this on Earth is the fact that we have so much oxygen on our atmosphere is indicative of life, that basically all the trees that are taking in the CO2 are releasing oxygen. If there were no trees on Earth, the oxygen would be gone within a few thousand years because it rapidly oxidizes. So there was this biosignature signal that was present, and it was incredibly, incredibly exciting and got a lot of media attention. And what ended up happening, though, is other groups then reanalyzed the signal. It was taken by a telescope called ALMA. And they said that the signal's no longer there. So it could have been a mistaken sulfur dioxide line, which also occurs a lot of times in Venus. So basically, did the scientists who had this initial claim just analyze their data wrong? That's entirely possible as well. The ultimate answer here is we need another observation to settle this, but so many scientists just don't think it was done validly that I don't think they're really going to get this observation anytime soon, which seems pretty silly, but it's kind of a weird astronomy politics thing. But so basically there's this potential for, something that could be in the upper cloud decks of Venus, and the jury is not 100% conclusive on that, is kind of the thing. As I said, though, I think in Monday's class, we're sending some future missions now to Venus, and they're definitely going to be studying that upper atmospheric cloud deck. So maybe this is something that we're going to talk about more in coming years in places like this class. So, okay, so Venus, maybe. Earth, yeah, but we already knew that, so that's maybe not as exciting. Mars, I just put, So, the case for Mars. Mars is a top priority for NASA. We talked about all the Mars rovers and all the exploring on Wednesday. And the reason is the conditions are really not too far at the end of the day compared to Earth. So, nice solid surface. Surface gravity, about 40% of our own surface gravity. It's cold, but not deadly cold. During the day, it can be above freezing, especially at the equator and when it's not winter on Mars. So it's not as bad as like Venus, where you just boil. There is a thin atmosphere, 1% of Earth's. So that's not like you can't breathe it, obviously. But in terms of like, can it protect you from things like radiation? There is some protection from having an atmosphere versus not having an atmosphere. And there's plenty of frozen water near the poles and probably elsewhere. So we're going to spend a couple of minutes discussing what we think this is like. So one of the big things that the Mars rovers have done is found a lot of evidence of rocks that look very, very similar to rocks on Earth when you have water present. So this, for example, is called mudstone. It basically happens when you have a riverbed and you have mud, and then that's becomes sedimentary, and you basically get these layers of rocks. So this channel here is consistent with if there was a giant stream of water in Mars's distant past that went through here, like in a river or something like that. Then we also have conglomerates, which are also formed by water. So basically, if you have water, you can see on the right, this is what they look like on Earth. So basically, over time, the rocks end up sticking together. Mars, it looks very, 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 very similar to that. We also see all these evidences of dried up channels that look for all the world like, water ran through there. You have these structures. I'm sure if you've ever flown on an airplane, you've seen these patterns of streams and rivers from higher up. I mean, that's pretty much exactly what they look like on our own planet. There's also evidence of ancient water from clay and erosion. So Jezero crater is where one of the Mars rovers landed. And this is an artist's conception on the left of what it would have looked like about 4 billion years ago and what it looks like today. So it looks like a lake that has an outflow going into it. The current frozen water evidence is basically that the northern cap has permanent water ice and some carbon dioxide ice. So there is dry ice there. And so just to give you an idea, there's also, these are the features that we can see from Hubble telescope. You have some features that are dark sand dunes, things like that. And then you have a smaller permanent cap, which is made up of both water and carbon dioxide. So basically, it's very, very evident that there's a lot of water ice. I mean, we can even see this. This is another picture, which is current frozen water evidence, which is just ice in the soil. So this is one of the Mars rovers. If you take a look, or sorry, it's one of the ones that's scraped. And you can actually see, okay, cool, there's, ice there. Okay, there's a lot of ice. Ice is good, but it's not liquid water, which is what we said we kind of need for our life. We do think there is evidence of liquid water on Mars. And we know this through underground radar signals. And a European orbiter named Mars Express basically found underground lakes. Basically, what you have is if you go down into the ice in the polar caps where you have more pressure, then you could have very brackish or salty water. that could then be a liquid water lake. So further down in the ice, probably a couple kilometers down, things like that. I should note, so one important thing about Mars and water, the reason we're also talking about solid water, we don't see any evidence for liquid water, is when the atmosphere is only 1% that of Earth, it's actually impossible to have liquid water like a lake or something on the surface of Mars. The reason is there's this thing called sublimation where, normally if you warm up ice, it becomes a liquid and then it becomes a gas. You actually skip straight from the solid phase to the gas phase. That's what's called sublimation. It happens when you have a very low atmospheric pressure like you have on Mars. So in current conditions, you couldn't have a lot of water sitting in a lake or something like that, but you could potentially further down where you would have more pressure and very salty water and things like that. So what we now think, and this has been, by the way, it's like the past decade or two type of shift in like when I was your age, not to sound too old, but it was like, we don't know if there's water on Mars. And now it's like, yeah, there were oceans on Mars. That's pretty settled science these days. So for its first few 100 million years, Mars had liquid water oceans. And this is an artist's conception of what this would look like on the right. So this is the graph of Mars. So you can see there's the lower regions up here. Also, not very many craters in that bit. So that would have been probably where the biggest ocean was. You probably had some other smaller oceans as well. And the last trace of this probably ended about 3 billion years ago, which is, a generous 1.5 billion years. Definitely longer than it took for life to show up on Earth. Life showed up on Earth pretty quickly, 4 point something billion years ago. So for within a couple 100 million years of the formation of the planet, as far as we can tell. What ended up happening to the water is, as I said earlier, like it went down into the rock that was present. And basically just because, so you had this water, you had initially Mars probably had a much more robust atmosphere. Over time, that atmosphere dissipated. And as I said, the conditions are just no longer able to sustain liquid water on the surface. That said, we can see evidence that we think there's some groundwater that happens on the surface of Mars. So here, what you see are channels. And these channels look for all the world, like if you have a sudden burst of water going outward and it trails down and then it ends up sublimating and disappearing. So we think this is basically if there's briny water or landslides triggered by carbon dioxide sublimation, you can have basically kind of like a little geyser going outward and then we'll leave behind these traces. So you can very briefly have some liquid water on the surface, but not too much. There's also, though, just like evidence, why do we think this is so recent? So this is a pretty cool image from a scientific study. These two images of the left are what these V-shaped alcoves, I guess is in gullies, look like on Earth. And on the right is what they look like on Mars. So, it just looks like for all the world, exactly like what we're used to seeing on our own planet. So that's pretty exciting. Okay, so we know there's water. We know there was water. All sorts of things to do with water. Now, how do we find life? So as we said on Wednesday, we've sent many, many missions to Mars looking for water and looking then for life. The first one of these was the Viking landers in 1976. There were tests on that lander to basically scoop up the soil and then see if there's any evidence of bacteria and things like that on there. The interesting thing was since 1976, we didn't really know about extremophiles that well. And they've now done those exact same Viking lander tests in desert conditions, in those deserts where, you have life just dried up for a couple years and it doesn't rain very often. And we know there's life there and it did not detect life. So these days, we think those tests were probably pretty inconclusive on determining if there's life in that soil in that initial sample or not. So something to think about. Maybe more compelling though was September of this year, so just 2 months ago or so, NASA announced what they called the closest we have ever come to discovering ancient life on Mars. And it's worth unpacking this for a few minutes to understand what exactly this was about. So the main interesting thing was this rock, which Yeah, I'm sure you're all a little disappointed that this is our best evidence of life, because what the heck are we looking at here? What is the interesting part here is this middle bit. So ignore like these side parts. You see that there's these spots. Can people see the spots? Yeah. So the spots are called leopard spots. This is like if we really zoom in. So it's the same pattern. And what you can see is, so there's the red rock. We talked about how Mars is rusty because of the iron oxide. But then you have these spots where you have the green outside, and then the inside, it's not as orange. Trust me on this. It looks like a little bit more tan colored or something like that. So this image, I mean, most of these images were taken by the Perseverance rover, and this is color coded here for basically the presence of two minerals that got scientists very, very excited from this rock. So the first is called Vivianite, which here is color coded as purple and pink. So, okay, it's basically this here, that type of feature. And the reason it's interesting is because Vivianite on Earth exists if there's a chemical reaction that uses up the iron present in rock. So we said earlier, all life needs some sort of energy to sustain it. And some of that life on Earth will leave behind traces of minerals that basically it used up some sort of chemical or some sort of minerals or chemicals present in the soil to extract energy and sustain itself. So Vivianite on Earth is sometimes a signature of this. So there's some iron oxidizing biota is what it's called. So you basically take the iron, you're stripping the iron from that oxygen, you're extracting your energy from that, and then you leave behind this chemical called this mineral called Vivianite. So it's a potential biosignature. That said, there's other ways you can form it, so it's not like a smoking gun. But then the other reason it was very interesting is right next to it. So it's color coded in yellow and green here. So there's some of it as well. Something called Greganite. And Greganite can only happen when sulfate is present, which is basically another one of these mineral reactions that life can do to extract energy. And it's another potential biosignature. So the sulfite would be created by biota, and then that's what's present in this mineral. So this is pretty in the weeds. This is not like your Hollywood, the space, the aliens show up in front of Los Angeles and we know we're not alone type thing. And it could all be a coincidence. Obviously, like, there's two minerals. They happen to be next to each other. Also, it happens to be in one of those ancient stream beds. So this is all very, very intriguing. But it could also be two lines of evidence pointing in the same direction, which is that there was life at some point on the surface of Mars that created these minerals. Perseverance does not have the equipment on board to tell us for sure that life is what put this there or something else. It's basically a bit too bulky to send to Mars. So one of the big reasons that we were discussing the Mars sample return, hope if that might continue going on in the future, is because basically they did leave, for example, already a sample of this rock. And I can guarantee you if Mars sample return happens, so we can bring the rocks back to Earth, this would be the first one they would pick up, no question. So where does this leave us in terms of life on Mars? Because that's really ultimately what I want to know. So this doesn't sound very conclusive, right? There's some evidence, but it's not totally there. And honestly, life in the universe, like we're very, very conditioned because of Hollywood to think that it's going to be like an instantaneous thing. Like we know we're not alone, society changes, and that's the end of it. But science doesn't really work like that. Science is usually we have some evidence that some people are like, oh, that's interesting. Then you get a little more, then you get more and more evidence. And then it's like, okay, this is a concluded thing. A good example of this is, water on Mars. So as I said, about 20 years ago, it wasn't really sure like if we have water on Mars or not. They started finding some evidence in some rocks, and then it was like, okay, but something else could be causing this. Then we saw some, erosion features, but something else maybe could be doing that. Then there's more and more evidence, and now we're at the point where I'm just like, yes, there was water, there were oceans of water on Mars. That is pretty settled science. So I think honestly, when it comes to things like life on Mars, it's pretty similar for a process where it's like, okay, We have some evidence, but maybe some other conditions existed to create this evidence. We don't really know. We're going to find a bit more, a bit more. And then hopefully, before you know it, before the end of our lifetimes, because that's what we really hope for, we'll be able to say, yeah, there's life on Mars. I mean, I know the microbes are not going to be as exciting as somebody else we could talk philosophy to, but it would be a pretty interesting place to start. It would tell us that life is hopefully fairly common in our universe. We're just going to do a bit of a teaser because I started by talking about the solar system. So we're going to talk more about the outer solar system starting next week. But so Jupiter, could there be life on Jupiter? I mean, we don't think so because we'll talk next week, but no solid surface. It is a gas giant and it's pretty cold. However, Jupiter has some moons, one of which is Europa. And you might have heard about Europa, and I think some of you guys did your projects on Europa because it's been very interesting because we think it might have oceans on it. So we're going to spend a minute kind of teasing Europa for when we get to it later in this class. So as a bit of a primer, Jupiter has four what are called Galilean moons, which is fancy talk for the big moons. Their names are Io, Europa, Ganymede, and Callisto. And we're going to talk about them all more in detail when we get to the moons. But the first thing to note is that the three innermost moons of Jupiter are tidally locked, which means that you have whenever one, here's a little animation, so take a look at Io here. Every single time Io goes around, it's the equivalent of 2 for Europa. So Europa takes twice as long exactly to go around Jupiter as Io. Ganymede is a 4-to-1 ratio. So it takes 4 times to go around exactly compared to 1 of Io's revolutions. What this means is, we talked about tidal forces with our own moon. Imagine now you had 4 moons and the crazy tidal forces that are going to interact with them and what ends up happening as a result of that. So there are some crazy effects. One of those effects, though, is so Europa is the second moon out from Jupiter. And the surface of Europa looks to be water ice. So you have these complicated cracks and features. If you've ever gone out on a frozen lake, you've seen these long lines, basically as the ice is kind of shifting around. And the other thing that's crazy about Europa is it has more water on it than we would have on our entire planet Earth. So we think it has liquid water under this ice. This ice is probably about 10 kilometers deep. And you have an ocean with an average depth of about 100 kilometers. And Earth's, for comparison, is about 3 kilometers deep. So giant, giant water world, basically. And this is another plug for Astronomy on Tap on Monday. If you guys want to learn more about this, Carol is a wizard on everything Europa. So yeah, we also think that it is somewhat similar to here. And the question is, how thick is the ice? Because, could we maybe drill down and then see the life forms and things like that? And I put a multi-billion-dollar question instead of a multi-million-dollar question. It's because there's actually a lot of people spending money to send probes there to learn what exactly this ice is like, and could there maybe be life existing in these oceans under Europa's surface. So the first one is a European Space Agency mission launched in 23, will arrive in December 2034. Jupiter's far, guys. It takes a long time to get out there is kind of the point here. It's going to do various flybys, so that's going to be something to look forward to. More important for this particular university, because Carol Patty is in the geology department, and she's one of the lead scientists on it. Europa Clipper, launched last year, will arrive in 2030. So, well, at least it's faster than the European one. And it's going to be an elliptical orbit of Jupiter, make 49 flybys of Europa. And then the hope is that basically you have radar and you'll be able to tell how deep that ice is. So I think they assumed it's like 10 kilometers deep or something like that for the ice. So hopefully then we'll be able to learn about that ocean and if anything is going on down there. Oh yeah, this is just kind of what it's going to be an orbit around Jupiter, and it's going to do all these crazy orbital dynamics, fly by Europa. It's never going to orbit Europa. And then when it's done, actually, they're going to deliberately crash it into, I think, Jupiter, just because you don't want any potential contamination, like in case some microbes hitched a ride. We just discussed, like, those microbes are pretty good at surviving in space, so do you really want to ruin microbial life over there? Hopefully not. And then we have, so we have Europa. As just a final one, we'll finish out the solar system. So Saturn, no solid surface, once again, even colder. Enceladus. So this is another moon of Saturn's, sixth largest moon, geologically quite interesting. It looks pretty similar to Europa in some ways, right? Okay, so we have a crater bit, don't get me wrong, but then you also have these cracks here. It also orbits Saturn's E-rings, whose lifespan should be a fairly short amount of time. Here's a picture of Saturn's rings. We're going to discuss the rings because I love the rings a lot more now that we're getting into the giants, but here's a great excuse to show off all the different rings of Saturn. And Enceladus, as a result, is basically living out here. I believe this is the E-ring out here. So the interesting thing about Enceladus is there was a probe called Cassini, which visited the Saturn system for many years, and it discovered these geysers. So these are water-rich plumes, very similar to geysers on Earth. So like in Yellowstone, Old Faithful, exactly that kind of geysers. They identified over 100 of them. So then they think the material after this geyser happens either falls back as snow, so the snow would be hundreds of meters thick on the surface of Enceladus, or it contributes to that E-ring, which is that outer ring of Saturn. So one of these very fine particle rings. So that's very intriguing. Then it begs the question, could there be another ocean out there? There were some observations taken by the Cassini mission that revealed Enceladus does also appear to have a liquid water ocean, which would be 26 to or 30-ish kilometers deep. So 10 times more than our Earth's ocean, still nothing to, sneeze at. And you might have some hydrothermal vents. We're not entirely certain what causes this. There's no orbital resonance like there is for Europa, which is like a very clear case for what's happening there. I did see an article actually just this morning that it does appear that Enceladus has some sort of heat source. So maybe it has, some sort of core or similar thing going on that is keeping that ocean liquid. We really honestly don't know. And we really need to send another probe out to Saturn. I don't think there's anything immediately on the docket, though. So this is probably going to be one that we're not going to know the answer to for a pretty long time. So Enceladus, maybe. Just to wrap up this solar system, Uranus, no solid surface, even colder. None of the moons appear to have these features that we think are related to liquid water oceans under ice or similar things. Neptune, no solid surface, getting really cold by the time you're getting out there. And Pluto and the dwarfs, solid, but very, very cold. I'll just wrap up with just one final thing, which is life outside the solar system. If aliens on the nearest exoplanet, which is Proxima Centauri, which is 4.3 light years from us, so the amount of time it takes, or amount of light takes 4.3 years to reach there. Light years is also a unit of distance. So light is the fastest thing that we know of in our universe. It travels at 3 to the 8 meters per second. So if a distance is how far light can travel, it is 4.3 years. So even at that closest vantage point, though, to Earth, what would they see if they were to look back at our solar system? I mean, we talked about the pale blue dot thing, but this is basically it. You would just see a star and you would not see anything else. Some people are like, oh, but we transmit out radio signals, things like that into outer space. Couldn't the aliens detect that? Basically, we don't transmit very much out into space. It's very inefficient to do that. It costs a lot of power to send out a signal strong enough to be detected at other worlds. And you're not going to tell, okay, even if you figured out we have all these different planets and things like that in our solar system, they could probably detect some of them with the techniques that we use to discover exoplanets. You're not going to tell even if, okay, we have a lot of oxygen on our planet. Is that put there because of algae or is it put there because of intelligent life? You don't know that just necessarily from a biosignature. So that's a little bit complicated. You basically have two ways outside of our solar system to figure out what is putting, or try to talk to intelligent life out there or find biosignatures of life. There's two main ways astronomers look for signals from other planets. The first is called the Search for Extraterrestrial Intelligence, or SETI. And the second is looking for biosignatures. So yeah, I'm going to talk about SETI for a second because I've actually done some SETI work in my research career. So this is a picture I took at the Very Large Array in New Mexico. This is a famous movie called Contact. Has anybody seen this movie? Okay, so it's a great movie. Basically, radio astronomers discover alien civilizations, and if you want to know why I became a radio astronomer, it's basically because of this film. Um, they use this giant radio telescope in part of the movie called Arecibo, which was the biggest radio telescope in the world. It was in Puerto Rico, and so this is basically a karst valley landscape where they put tiles kind of in this natural forming bowl to create a giant radio telescope, and then this was the I think I have another picture here. Yeah, so this was the feed horn that they would use to then identify where the signal is coming from. So I went to Arecibo in September 2019. I got married, and then we had to get married quickly because my husband was Dutch, so we got a green card marriage. Don't tell them. Yeah, anyway. Uh, we like each other, guys. It's fine. But anyway, so we were like, let's go on honeymoon, but we can't leave the United States. So we went to Puerto Rico. And this is how you can tell if you're like meant to be with someone. Because I was like, oh, we're going to Puerto Rico. We just got like a, beach resort somewhere. I was like, oh, but, I'd really like to see Arecibo, but I'm on my honeymoon. I don't want to like, yeah. And then he was telling me, he's like, oh yeah, isn't Arecibo in Puerto Rico? And then I was like, yes, we have to rent a car. We have to drive here. This is the day that, so that's how you know that you're really made for each other. So I got to see Arecibo, and it was very exciting because it is the Chinese have now built a bigger radio telescope. It's they found a 1 kilometer sized valley. So it's an order of magnitude basically bigger than what Arecibo is. There were people living in the village, but in China, you just kick them out and you don't have that problem. And it's actually very lucky that I went in September 29 and got to see Arecibo because in 2020, it collapsed. So I'm going to show you guys a video because it's pretty wild. If this will let me. So they knew it was going to collapse. Basically, Hurricane Maria had really deteriorated it. They'd also hadn't kept up the maintenance. And then this was in December 1st. One morning, it just completely collapsed. And then there's one more video. It's bigger. So that wasn't great. But then they had a drone up at the time, so they definitely knew that it was about to happen. And this video is just insane, so I'm going to show it to you guys. So the cables start to snap, and the entire thing just goes. Probably one of the biggest catastrophic collapses of the recent decade. And that was the end of Arecibo. The problem is there's not much money and interest. Like the way it was built is very complicated. There was some US military interests, and there's no longer those interests. So they're basically not going to rebuild Arecibo. And we kind of lost a cool instrument that was also very integral. They did a lot of SETI stuff with this telescope. So it was kind of a shame. They're currently in the process of basically the NSF who ran this had the agreement with the Puerto Ricans that they would return the valley to its original state once they were done with it. So I believe they're still in the process of that. So, yeah. Yes.
Was there a reason for Puerto Rico?
Um,
Because of the location?
Yeah, so Puerto Rico has a lot of mountains, which are very good to hide from man-made interference, especially in like the 50s and 60s when they first built this. There was not a lot of stuff being, and this is like a remote part of Puerto Rico as well. And then this karst landscape also gave you these bowls that were the right size, is kind of the answer. So it's the best terrain in the United States, or to do this. Yes, so I did SETI. When I did SETI, it was in California at what's called Hat Creek, California. It's a Allen Telescope Array is the name of the telescope there. Paul Allen of Microsoft gave a lot of money to build this array. It's about 5 hours from here. This is actually the closest radio telescope to us here in Eugene. This is Mount Lassen. If you like your national parks, then you know Mount Lassen National Park is one of the ones in Northern California. So it's an absolutely beautiful site. I got to work for a woman named Jill Tarter when I was there, and she's kind of a very famous icon in astronomy. because she basically founded and ran the SETI Institute for years and years. She spent her entire life, basically, she recently retired, but she spent her entire life looking for alien signals, which I think when you're like 25 and you think to yourself, I'm going to spend my career looking for this thing that I might never find, it'll be okay, versus when you're at the end of your career and then you're like, I never found it, then that's a little bit demoralizing. But she's a very, very the most intelligently intimidating person I ever met. I basically spent the entire summer thinking, please don't think I'm stupid. But yeah, that was a pretty cool experience. Did not find aliens, or else, this is probably not the first time you would have heard about this entire experience. So just as a final thing, I mean, SETI, we're going to talk about biosignatures more later in this class for telescopes that might find those. But the SETI stuff, I'm just going to say, like, I think this is one of those things. I'm very happy other people are doing it. I don't think I'm going to base my scientific career on it because, it would be very cool if, we get a bolt from the blue signal from radio or radio signal from alien civilizations. But it's also just really, really hard. It turns out it's a very big sky. I mean, you could even just be pointing there and the aliens are talking to you from over there and you would never see it. Things like that. So that's just kind of something that I've dabbled in my astronomical career that I thought was pretty fun for a Friday afternoon lecture. Um, yeah, so we'll see. Maybe someday, though, the SETI people will come out and we'll finally have somebody to talk to with several light years, lag time in the conversation.